Okay, so let's talk about long division. So let's take a look at this problem over here. This is a long division problem we learned way back when, and before they allowed us to use calculators, we had to figure out how to take 32 and divide it into 11,479, correct? Well, here's the thing with long division that, I was never taught when I was a kid. What we're trying to do is systematically wipe out every number that's underneath the division symbol. With me? Okay, now here's the deal. They said, hey, does 32 go into 1? We put a 0 because it didn't. Does 32 go into 11? It didn't. We put a 0. 32 into 114. Okay, let's figure out how many times. Well, something that actually gave us some assistance was actually looking to see how many times 3 went into 11, right? Because that might give us a good idea of how many times 32 went into 114, right? Well, 3 went into 11 3 times, so 32 would go into 114, hopefully 3 times, right? So we'd put the number up top, wouldn't we? Okay. Now, let's look over here at this problem. They're asking us to divide this polynomial. So, here's my division sign, right? The numerator always goes underneath. Understand that. The numerator is always underneath, and make sure it's in descending order. The denominator is always on the outside. And so now we're trying to figure out how many times x plus 1 goes into this polynomial, right? Well, here's the key. Over here, remember, my brain was like, well, I don't know how many times 32 goes into 114, but I do know that 3 goes into 11 3 times. So we looked at the first number on the outside and almost the first number on the inside, right? Well, with dividing polynomials, that's key. I am going to look at the first term on the outside with the first term on the inside, because I'm going to try to do the same thing and systematically wipe out each of these terms underneath the radical sign, or pardon me, under the division sign. So, I'm going to look at the first term of x, and I want to see how many times x goes into 2x squared. Well, I'm going to tell you right now, I don't ask myself that question. What I ask myself is this: what do I need to multiply by the x to make it like a 2x squared? Yeah, I need to multiply it by a 2, and I need to multiply it by another x. Agreed? Because this x is missing a 2 and another x to get the squared. Do you agree? Okay, so back over here a second. After we put the number up top, what do we do with it? Yeah, we take the number we just put on top and we multiply it by the number on the outside, don't we? Well, over here, what are you going to do with the number up top? Yeah, you're going to take the number you just put on top and you're going to multiply it by the outside, aren't you? Okay, back over here. What's 3 times 32? Good, this gives you 96. And so you put the 96 under the 114, don't you? All right. Over here, what do I get? I get 2x squared plus 2x. So where do I put the 2x squared? Under 2x squared, because they are like terms. And where do I put this plus 2x? Under the minus 6x, because they are like terms. Agreed? Okay, back over here. Now that I've done this, now that I've done my multiplication, we subtract, don't we? And when we subtract, we're going to get 22, aren't we? Okay, back over here, I'm going to subtract. Agreed? Well, my question to you is this. When I subtract, this whole thing is getting subtracted, isn't it? So I'm not just minusing the 2x squared, I'm also minusing the positive 2x. So this minus sign doesn't just go to the 2x squared, this minus sign also goes to the positive 2x, doesn't it? So, let me do a little bit of cleaning up here. I am basically taking 2x squared and minusing 2x squared, aren't I? What happens? They cancel, which is what we wanted to happen, right? But then I've got to take the minus 6x and subtract 2x. What do we get? Yeah, we get a negative 8x. Remember, I'm taking a negative 6x and I'm minusing this 2x. Negative 8x. Cool? Okay, back over here. After we subtract, what do we do next? Yeah, you bring down the next number, so that 7 comes down, right? Over here, after we subtract, what do we do next? Yes, you bring down this minus 8. Over here, what happens? We start all over again, don't we? So what happens over here? We start all over again. And my first term on the outside is going to help me wipe out this first term on the inside. With me? Okay, so same question. The question I ask myself is this. What do I need to multiply by this x to make it look like a negative 8x? Yeah, I need to multiply it by a negative 8, don't I? Once I put the negative 8 on top, what do I do with it? I multiply by what's on the outside. So I'm going to take the negative negative 8 and multiply by the x plus 1. Agreed? What do we get? Negative 8x minus 8. Agreed? And then I put negative 8x under negative 8x. I put this minus 8 under this minus 8. And then what do I get to do? Yes, I get to subtract. Now remember, how many times are you subtracting? Twice. So this first one gets a negative and so does the second one. Yes? Well, the double negative makes it positive. This double negative also makes it positive, which means I have a negative 8x plus 8x. Cancels out, which is what we wanted to happen, right? And then we have a negative 8 plus 8, and we get 0. Well, that canceled out also, didn't it? Bonus points! Because do I have anything else to carry down? No, I do not. So, 2x squared minus 6x minus 8 divided by x plus 1 gives me 2x minus 8. Cool? Okay, we're going to do some more problems, but understand the long division on polynomials is just like the long division that we did over here when we first learned to do long division way back when as a kid. Now, by the way, do you remember how you check your answer with long division? Oh yeah, there you go. What's the opposite of division? Multiplication. So, for me to check my work, I would have to take the x plus 1 on the outside and multiply by the answer I got, 2x minus 8. And when I do this distribution, I better get that numerator of 2x squared minus 6x minus 8. Agreed? Cool. Hang in there. Got another example for us. Okay, so let's look at this second problem. They're asking us to divide, right? So, let's make certain that this polynomial is in descending order. Is it? Excellent. Is this one in descending order? Good. So now, which one goes underneath? The first one or the second one? The first one, because I'm taking this third degree polynomial and dividing it by the second one. So, 4x cubed plus 7x squared plus 8x plus 20 goes underneath. And I'm dividing it by the 2x plus 4. I'm trying to take 2x plus 4 and put it into this third degree polynomial. Okay, so now, check it out. Remember, I'm trying to systematically wipe out every number underneath, or every term underneath. And what's going to help me is the first term on the outside. So the first term on the outside in the beginning has helped me wipe out this first term on the inside. So What do I need to multiply the 2x by to make it look like 4x to the third? Good, some of you got the answer. Let me phrase my question a different way. What is the 2x missing to look like the 4x to the third? Yeah, it's missing a 2, and it's missing an x to the power of 2, isn't it? It's missing a 2, and it's missing 2 x's. Good? Okay. So, what do you do? Remember, this is long division. What do you do when you put a number up top? Good. You're going to take the 2x squared you just put on top, and you're going to multiply it by 2x plus 4. Excellent. What do we get? We get 4x cubed plus 8x squared. Awesome. Where do I put the 4x cubed? Underneath the 4x cubed. Where do I put the plus 8x squared? Under the 7x squared. Remember, like terms under like terms. And now, after we've multiplied, remember, this is long division. What do you do next? Yes, you subtract. How many times? Good, twice. I'm going to subtract off the 4x to the third, and I'm going to subtract off this 8x squared, right? Okay. 4x to the third minus 4x to the third cancels, which is exactly what I was trying to make happen, right? Yay! 7x squared minus 8x squared. What do you get? You get a negative x squared, don't you? And after you subtract, good, I bring down the next term. With polynomials, I recommend bringing them all down. With me? Okay, and then I start over, don't I? I'm trying to get the 2x to wipe out the negative x squared, aren't I? Okay, so be careful on this one. In front here is a negative 1, isn't it? So what do I have to multiply the 2 by to make it, first of all, into a 1 and then a negative? So I know I'm going to have to multiply it by a negative number, right? Okay, so 2 times what is going to give me 1? Good. 2 times a half is going to give me 1, isn't it? You know, like some of you are like, wait, how'd you get that? Remember my question. My question was 2 times what is going to equal a negative 1/2? Sorry. I was ahead of myself. Let me try that question again. 2 times what number, I'm going to call it z, is going to give me a negative 1. To solve for that z, wouldn't you have to divide both sides by 2? So wouldn't you get z equaling a negative 1/2? That's what I put on top. Got it? Okay. Now I need this x to look like an x squared. Good, so I need one more x up here, don't I? Does that make sense? Okay. So you put a fraction on top. So what? Let it be. If it's supposed to be a fraction, it's supposed to be a fraction. All right. Long division, you just put a number up top. What are you supposed to do? Good. I'm supposed to take the number I just put on top and multiply it by the outside. So, negative half times 2. Yeah, that's a negative 1x squared. A negative half times 4, negative 2x. Got it? Okay, so negative x squared under negative x squared, negative 2x under the positive 8x. And remember, this is a long division, so what do you get to do? You get to subtract. How many times? Twice. This gets subtracted and this gets subtracted. You're minusing a negative. Good. 2 negatives make a positive. You're minusing a negative. 2 negatives make a positive. Which means you have a negative x squared plus x squared. Yay! They cancel out. That was our goal. Yay! And now you've got a positive 8x plus 2x. Good, 10x. And then we bring down that only number left, the 2, correct? And then we start all over again, don't we? Good. So, I'm going to take the first term and wipe out the first term. So, what do I multiply the 2x by to make it look like a 10x? Good, a 5. And the 5 is what, positive or negative? Good, positive. Because I'm trying to make them look exactly the same. Remember that. You're trying to make them look exactly the same. Got it? All right. So, when you put the number up top, what do you do next? You multiply it by what's on the outside. So I'm going to take this 5, positive 5, and multiply it by the outside, which is 2x plus 4. Agreed? And then, good, you get 10x plus 20. Where does the 10x go? Under the 10x. Where does the 20 go? Under the 2. And then what do you get to do? Excellent. You get to subtract, don't you? How many times? Twice. Minusing the 10x and minusing the 20. So, yay, the 10x's drop out. That was my goal, right? And now I have a positive 2 minus 20. Good, a negative 18. And I start all over again, don't I? Okay. I'm trying to make a 2x look like a negative 18. But this negative 18 has no x's with it, does it? So technically, it's not the numbers with dividing, long division of polynomials. It's not the numbers you look at to see who's smaller. Write this down. To see if this is smaller, it's the x's you look at. No x's here make this term smaller than this first term on the outside that has an x. Again, this minus 18 that has no x's, the fact that it has no x's makes this term smaller than the 2x. So that means the negative 18 is your what? Yeah, that's the remainder. Are you with me? That is your remainder. So, you're like, well, how do I write this? So I'm going to start writing my answer over here because I have more room. So I have 2x squared minus 1/2 x plus 5, right? This 18 is a negative, so minus. Now understand what you're trying to do. You're still trying to take this negative 18 and divide it by the 2x plus 4. So that's how I'm going to write it. I'm going to take the negative 18 and I'm still trying to divide it by the 2x plus 4. Here is the answer to this long division problem. With me? Okay, so if you're asking yourself, well, how do you check this? Like we've done in the past. I'm going to take my answer up top and multiply it by the outside. And then once I finish that multiplication problem, I'm going to minus 18 from it. And that better give me this third degree polynomial right here. Cool? Okay, hang in there. I got another one of these. Okay, let's look at this third problem. They're asking us to divide, so good. This is in descending order, isn't it? So is what I'm dividing by, right? Okay, let's start getting this problem written down. So the x squared minus 2 goes on the outside. Do you notice on the polynomial that goes underneath, I'm missing an x to the 4th, aren't I? Now, in long division, it's optional to put that in. For some of you, you're going to want to put that in. Why? Because you're visual enough, you're like, I need to see it. Where is it? By the way, how many x to the 4ths did they write in the original problem? None. And in math, none means what number? Good, 0. So plus 0x to the power of 4. Got it? Okay. And then minus the x cubed plus 4x squared minus 12x minus the 8. Okay, so remember, just like we've been doing, we start with the first term, and the first term is supposed to wipe out the first term. So, what do we need to multiply this by? We need to multiply it by a 3 and an x cubed. And once you put this on top, what do you do next? You multiply by what's on the outside. So, I'm going to give you guys a few moments to multiply by what's on the outside, because I ran out of board space. Good, so I heard you. You got 3x to the 5th minus 6x cubed, huh? Well, I'm putting that minus 6x cubed under the minus x to the 3rd. So it looks like I skipped right over the x to the 4th, didn't I? Well, sometimes that happens, but it doesn't hurt to write down what was missing, because I may have needed it, and I still may need it. We'll see. So now what after you multiply? Good, subtract. So this gets subtracted and this gets subtracted. And this double negative makes it a positive. Good. So 3x to the 5th minus 3x to the 5th. Yay! Cancels out. Nothing under x to the 4th, so I don't have to write this down because there's nothing to do here. And then negative x cubed plus 6x cubed. Good. It's a positive 5x cubed. After we subtract, good. We write down the rest of the polynomial. We bring it down. All of it. That's my recommendation when we're doing the long division. For polynomials, write all of it down. Good? Then we start over. So, x squared on the outside needs to look like the 5x cubed. What do I need to put on top? Good, I heard you. A positive 5x. Because there's 2 x's there and 3 there. I need one more. Then what? Good. Take the positive 5x and multiply it by the x squared minus 2. Go ahead. I'll wait a few moments. I heard you. What'd you get? You got 5x cubed minus 10x. Oh, well, that minus 10x is going to go under the 12x, right? And then we get to, we get to subtract, don't we? So this gets subtracted and the double negative makes it positive. So these guys drop, don't they? Now, nothing went under the 4x squared, did it? Okay, so let me back you up a second. Over here, nothing went under the 0x to the 4th, did it? So 0x to the 4th plus 0x to the 4th is, this would have been just a 0 here, which doesn't do anything for us. 4x squared plus nothing is still 4x squared. So that's important for us to bring down. Are you with me? Because that 4 I'm going to have to deal with. 0 doesn't do anything for us. Good? This was just a placeholder and we didn't need it. Good? Okay. And then I have a negative 12x plus 10x. Good. Positive 2x. And then oops, not a positive 2x. What am I saying? Did you guys catch it? I hope you did. It's not a plus 2x, it's a minus 2x. You know as well as I do, right? Good? Then we start all over again. So the x squared on the outside and the 4x squared on the inside. Good, I heard you. Put a positive 4 on top. Then what? Multiply. So I'll wait a few moments. What do you get? Good. A positive 4x squared minus 8. And then we get to subtract. How many times? Twice. Minus there, and this becomes a positive, doesn't it? Okay, these cancel, don't they? Yep, that becomes a minus 2x, and these 8's cancel, don't they? And start all over again. X squared and a negative 2x. Yeah, that x is to the power of 1. The x here is to the power of 2. So technically this x to the power of 1 is smaller than this x to the power of 2, isn't it? So the minus 2x is your what? Remainder. Good job, you guys. So that means I have minus 2x over x squared minus 2. With me? Awesome. Okay, so my recommendation is to replay this video as many times as you need to understand long division of polynomials. I actually find long division of polynomials much simpler than just long division of numbers, to be honest with you. So, have fun with this stuff, and I'll catch you on the flip side.